Welcome to the next section of differential equation. Today we study the solution of differential equation. If I having equation y dx minus x dy equal to 0. Now how to find the solution of this equation? Then this equation becomes m will be y and n will be minus x. If I partially differentiate m with respect to y, it gives 1 and n with respect to x it gives minus 1. So from this del my del y is not equal to del n by del x. That means this is non-exact differential equation. If I got del m by del y equal to del n by del x, so that will be the exact differential equation. So how to find solution of this equation? In this we multiply this equation by 1 by y square. If we multiply 1 by y square with this equation, the equation becomes y upon y square dx minus x upon y square dy equal to 0. Here y get cancelled. So 1 by y dx minus x upon y square dy equal to 0. Now this is our m, this is our n. So del m by del y it gives minus 1 by y square and del n by del x it gives minus 1 by y square. Means this forms the exact differential equation. By simply multiplying 1 by y square, our equation x dx minus x dy become exact. So this 1 by y square is called integrating factor. So to solve this type of problem we require integrating factor. Now there are different rules to find the solution of non-exact differential equation. The rule first, if equation m dx plus n dy equal to 0 is the homogeneous equation and mx plus ny is not equal to 0, then integrating factor will be 1 upon mx plus ny. This is the rule first. Now rule second, if equation f of x comma y dx plus f of x comma y dy equal to 0 and mx minus ny is not equal to 0, then integrating factor will be 1 upon mx minus ny. Here is difference is, if we got a homogeneous equation, so our integrating factor will be 1 upon mx plus ny. If our equation is not homogeneous, then we use this rule. I show you with the help of example. Example, x square y dx minus x cube plus y cube dy equal to 0. This is our equation. To find the solution of this equation, first we find this equation is exact or not. So this is our m, this is our n. If I found del m by del y, so that will be x square and del n by del x, that will be minus 3x square. That means this is not a exact differential equation. So we use first or second rule. By looking this equation having degree 3 is 2 plus 1 and this having degree 3. That's why this is a homogeneous equation. So for that we use the rule first. So integrating factor will be 1 upon mx plus ny equal to, what is the value of m? It's x square y into x plus, here minus, for that we put minus sign, x cube minus y cube into y. So our integrating factor will be 1 upon x cube y minus x cube y minus y raised to 4. This x cube y get cancelled, so the integrating factor will be minus 1 by y raised to 4. So this is our integrating factor. By multiplying this integrating factor to this equation, we get exact differential equation. So x square y upon y raised to 4 minus y raised to 4 dx minus x cube plus y cube dy equal to 0, multiplying by minus y raised to 4. So we simplify it, it gives x square upon y cube minus sign dx. Here we try to split it, it gives x cube upon y raised to 4 minus plus 1 upon y dy equal to 0. Now this is the exact differential. You can find this in this way. So the solution of this differential equation will be integrating m dx plus integrating n dy equal to 0. Here y is constant while taking integration, and here only y term we get. So how to find the integration? Now we are totally deal with this equation, not previous one. So integrating minus x square upon y cube dx plus n will be only we take the 1 by y, it's 1 by y dy equal to c. So here y cube is constant, integration becomes cube upon 3 y cube minus sign as it is plus 1 by y is log y equal to c. So this is our solution of non-exact differential equation by using rule first. Next problem, we having the equation y 1 minus x square dy minus x 1 plus xy dy equal to 0. Now first thing we find the del m by del y. This is our m and this is our n. So del m by del y gives you 1 minus xy and del n by del x gives minus 1 minus 2xy. So again we found that this is not an exact differential equation. We have to use rule 1 or rule 2. By looking this equation, this is not homogeneous because this having degree 1, this having degree 2 or 3, because by multiplying this it getting degree 3, it is also degree 1 and degree 3. It's not a homogeneous one. So for that we use the rule number 2nd. In the rule 2. In rule 2, integrating factor will be 1 upon mx minus ny. Only difference is minus sign. From rule 2, integrating factor will be 1 upon mx minus ny. So mx value y 1 minus xy into x minus n value will be its minus sign, that's why it getting plus x 1 plus xy into y. So integrating factor will be 1 upon xy minus x square y square plus here we get xy minus x square y square, plus x square y square. This x square y square get cancelled, our integrating factor becomes 2xy. So this is our integrating factor. By multiplying this factor to this equation, we get the exact differential equation, and then we follow the rule of exact differential equation. Now we multiplying integrating factor with this equation, our equation becomes y upon 1 minus xy upon 2xy dx minus x 1 plus xy upon 2xy dy equal to 0. Here y getting cancelled, here x getting cancelled, 2 getting cancelled. So the equation becomes 1 by x minus y dx minus by y plus x dy equal to 0. Now the solution is the integration of m dx minus plus n dy equal to 0, but here we taking only y term and here y equal to constant. M we take as 1 by x minus y dx plus integration of only y term is here, so that will be minus 1 upon y dy equal to 0. Here we getting 1 by x means integration will be log x minus it having xy because y is constant minus integration of 1 by y with respect to dy, it gives log y equal to c. This is our solution of differential equation. Now we understand rule 3 and rule 4. In rule 3, if equation in the form m dx plus n dy equal to 0 and 1 by n del m by del y minus del n by del x is the function of x, that equal to function of x, then integrating factor will be e raised to integration of fx dx. The rule 4, if the equation in form m dx plus n dy equal to 0 and 1 by m del n by del x minus del m by del y is the function of f of y, means equal to function of f of y, then integration factor will be to f of y dy. Means difference is that in place of 1 by n here having 1 by m, and in place of del m by del y minus del n by del x, it reverse del n by del x minus del m by del y, and if we having the function of x, then we found the integrating factor will be e raised to f of x dx, and if we find f of y, then integrating factor will be e raised to integration of f of y dy. These are the rule 3 and 4. I show you the rule 3 example, then you practice for the rule 3 and rule 4. Next example, x square plus y square plus 1 dx plus x bracket x minus 2y bracket complete dy equal to 0. Now by looking at this equation, we don't find this is the homogeneous one because here having x square y square 1, so not a homogeneous equation. So for that, this is our m, this is our m. So del m by del y gives us 2y and del n by del x gives us 2x minus 2y. By looking this is not an exact differential equation. So for that we have to use rule 3 or 4 because this is not a homogeneous one, or this having the 1 also, it's not a only function of x and y. So for that we have to use rule 3 or 4. If I use rule 3, then equation becomes, the rule 3 will be 1 by m del, the rule 3 will be rule 3 will be 1 by n bracket del m by del y minus del n by del x. If we got a function of x, then we use the integrating factor e raised to integration f of x dx. So find it 1 upon, it's our m, x into x minus 2y in bracket del m. So what is the value of del m? It will be 2y minus del n by del x. So it will be 2x plus 2y. By simplifying this bracket term, 1 upon x minus 2y, it will be taking minus 2 common, x minus 2y. So like same, so this get cancelled. Our equation becomes minus 2 upon x, means this is the function of f of x. By finding 1 by n del m by del y minus del n by del x, we got a function of x minus 2 by x. So our integrating factor will be e raised to integrating f of x dx. So that will be integrating minus 2 by x. It gives minus 2 log x. Here having dx. We give e raised to minus 2 log x. So that becomes e raised to log 1 upon x square. When we having e raised to log, so that will be 1 upon x square. So this is our integrating factor. By multiplying this integrating factor to this equation, we got exact differential equation. Integrating factor will be 1 upon x square. By multiplying this integrating factor with this, we get x square plus y square plus 1 upon x square dx plus x into x minus 2y upon x square dy equal to 0. We make it simple. It gives 1 plus y square upon x square plus 1 upon x square dx plus, here x is getting cancelled, 1 minus 2 y by x dy equal to 0. Now we find the solution of differential equation. The solution will be, it's a integration of m dx plus integration of n dy equal to 0. But here we take only y as a constant and here only y term. So here we having m. So integration of 1 plus y square x square plus 1 upon x square dx plus, here we having only 1 as y term because this term contain x, so we neglect that. Integration 1 dy equal to c. By integrating we got x minus y square upon x minus 1 by x plus y equal to, so our final equation will be x plus y minus 1 plus y square divided by x equal to c. This is our final solution.